Okay, guys, some linear relationships today. We're going to define two terms, linear and y-intercept. Linear is just when something is graphed, it's a line. Actually, how did I put this yesterday? Let's see. When a graph is a line, let's just say that. Looks like a line. And when there's a consistent pattern between y and x. For instance, like if x is, your x values are going up 1, 2, 3, 4, your y values are going up like 3, 6, 9, 12. It's the same pattern for your x's, and then a different but the same pattern for your y's. Between x and y. Looks like a line. It's linear. Y-intercept is where the line crosses the y-axis. And it could also be where the starting point of a situation, right? For like it's a word problem or whatever. It's going to be it right there. Starting point of a situation. Up until this point, we've only ever seen our graphs start at 0, 0. This is when we fully move to 8th grade and we see them start at a different point than 0, 0. So that's your y-intercept right there. We have this pattern right here, 1, 2, and 3. Basically, if it keeps growing the same way, what's going to be your 4th, your 5th, and then your 10th, right? So I typically look at it in terms of colors, and so if I just look at my reds, because that's going to be easiest, right? The next pattern is going to have 1, 2, 3, 4 reds, and then 5 reds, and then 10th reds, 10 reds. It's just going to match the step, right? So for red, I have 4, 5, and 10. It's just going to be, step 4, 5, and 10. It's just going to be 4, 5, and 10. Now for blue, when we look at this, right, it starts at 3, and it goes to 6, and then it goes to 9. So it's just going up by 3 each time, right? 3 times 1 is 3. 6 times 3 is 2. Let me say that again. 1 times 3 is 3. 2 times 3 is 6. 3 times 3 is 9. 4 times 3 would be 12. 5 times 3 would be 15, and then 10 times 3 would be 30. Now for the yellow, I like to think of this in terms of area, right? So I have 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 would be 16. The 5th step would be 5 times 5, 25, and the 10th step would be 10 times 10 is 100. Hello, Ms. Struza. You're on video. Would you like me to pause? Okay. If you give me like 8 minutes, I'll be done with it. You're good. Yeah, so then the second one right here, this is basically figuring out the algorithm for it and kind of generalizing it to an equation or a formula. If I look at the reds, it's just going to be equal to the step number, right? So it's just going to be n. Right? That's our variable right here. Blue is going to be 3 times our step number. And then yellow is going to be your step number times itself, which is the same thing as n squared. Okay, so these are our consistent patterns right here. These two would form a linear relationship. This would form a parabolic curve. So these two would be linear. This one would be nonlinear. Summer reading assignment. After reading the first 30 pages of the book, she plans to read 40 pages each day until she finishes. She makes a graph. After day 1, she reaches page 70. Okay, which matches the point 170 right here. She made on the graph. After day 4, she reaches page 190, but it doesn't match what she did on the graph. So she's not sure what went wrong since she knows she followed her reading plan. So we're going to fix her mistake. Sketch a line showing Lynn's original plan on the axis. So she started with 30 and then is reading 40 pages a day. So her starting point is 30 rather than 40. She basically mixed these up with her y-intercept. Actually, let me make that a little more central. with her y-intercept at 30 and her slope of 40. And then she's going to go up 40, so 30 plus 40 is 70. So it actually matches this point on day 1, but day 2 is where it starts to diverge. So 70 plus 40 is 110. So right here. And then 110 plus 40 is 150 for day 3 right there. So we can see that her actual correct line is steeper than the original line she drew. And the reason she did that, or the reason it's wrong, is because she flip-flopped her numbers right here, right? She started at 40 rather than starting at 30, and then she went up by 30 instead of going up by 40. What does the y-intercept mean? It means that she started with 30 pages. How do they compare? Correct line is steeper. Easy peasy. So just talking about kind of what these things mean, how we interpret them. What does the slope mean in this situation? It just means she went up, or she read 40 pages per day. How do those two slopes compare? Oh, actually, that correct line is steeper should go down here. And how do the y-intercepts compare? The original is lower than the new one, or than the incorrect one. Or the correct one is lower than the incorrect one. So let's see, JD's grandparents started the savings account for her in 2010. We can think of that as year 0. The table shows the amount in the account each year. It's going up by 2 years. Right, so the same thing. 2010 is when it started, so it's year 0. If the relationship is graphed with the year on the horizontal, so it's our x-axis, and the amount in dollars on the vertical, what is the y-intercept? So the y-intercept is basically how much money she started with. So 600, or you could look at it as 0, 600. What does it mean? It means that's how much money her grandparents gave her. How much money her grandparents gave her. It's the starting point of the situation, which is exactly what we said for our definition of y-intercept. Okay? Here's a graph showing the amount of money paid for a new cell phone in the monthly plan. What is the vertical intercept? This is a typo. This should say y-intercept. That is right there at 200. So you say 200, or you could say 0, 200. What does it mean? It means the cell phone cost $200.